Good day everyone, I am Therese May Jimabala, a BSc 3 student, and I am here to discuss all about cubic spline interpolation. So before we go over to the definition of the cubic spline interpolation, so let us define first what is splines. So it is an alternative approach to using a single n-1th order polynomial to interpolate between n points is to apply lower order polynomials in a piecewise function to subsets of data points. These connecting polynomials are called spline functions. Splines minimizes oscillations and reduce round-off error due to their lower order nature. So a cubic spline interpolation is the most common piecewise polynomial approximation, uses cubic polynomials between each successive pair of nodes, and is called cubic spline interpolation. So cubic spline interpolation is a special case for spline interpolation that is used very often to avoid the problem of Runge's phenomenon, where Runge's phenomenon is a problem of oscillation at the edges of an interval that occurs when using polynomial interpolation with polynomials of high degree over a set of equispaced interpolation points. So a general cubic polynomial involves four constants. S sub j of x is equal to a sub j plus b sub j x minus x sub j plus c sub j x minus x sub j squared plus d sub j x minus x sub j cubed. So the four constants are a sub j, b sub j, c sub j, and d sub j. The cubic spline procedure ensures that the interpolant is not only continuously differentiable on the interval, but also has a continuous second derivative. So spline or cubic spline interpolation, this method gives an interpolating polynomial that is smoother and has smaller error than some of other interpolating polynomials such as Lagrange polynomial and Newton polynomial. So sa equation, imukuhaon ang first derivative, and then after sa first derivative, you get the second derivative. Then using the derivatives, you substitute the values of x to the first and second derivatives, and then you get the new equations. So from linear and quadratic spline explanations, we set conditions for a natural cubic spline as, so this is the condition 1, then condition 2, condition 3, and condition 4. So mauna siya sa condition 3, sa imuhang equation, you will get the first derivative, and then after getting the first derivative, you get the second derivative, and then you substitute the values of x to get another equations or new equations. So before we proceed to the examples of spline interpolation or cubic spline interpolation, let us define the difference of linear spline, quadratic spline, and cubic spline. So linear spline, in linear spline, derivatives are not continuous and not smooth. So in here, first order splines find straight line equations between each pair of points that go through the points. And then we have the quadratic splines, continuous at first derivative. So second order splines find quadratic equations between each pair of points that go through the points, match first derivatives at the interior points. Lastly, we have the cubic spline. So it is continuous at first and second derivatives, and it is smoother. So third order splines find cubic equations between each pair of points that go through the points, match first and second derivatives at the interior points. So while data of a particular size presents many options for the order of spline functions, cubic splines are preferred because they provide the simplest representation that exhibits the desired appearance of smoothness. So linear splines have discontinuous first derivatives, quadratic splines have discontinuous second derivatives, and require setting the second derivative at some point to a predetermined value. Then quartic or higher order splines tend to exhibit the instabilities inherent in higher order polynomials. So for us to understand what is a cubic spline interpolation is, so here are some examples. So here is the first example of cubic spline interpolation. So example number 1. So find A, B, and C that makes this a cubic spline. So S sub 1 of x is equal to 2x cubed minus 3x squared plus 3x minus 4, and S sub 2 of x is equal to x cubed plus ax squared plus bx plus c if x is greater than or equal to 0 but is less than or equal to 1, and x is greater than or equal to 1 but is less than or equal to 2. So the first step is, so s sub 1 of x is equal to 2x cubed minus 3x squared plus 3x minus 4x. So we substitute the 1, or let's say x is equal to 1, so substitute the 1. So the answer is negative 2. Then after getting the value of this, so you need to get the first derivative of this equation. So the first derivative of this equation is s prime of 1 is equal to 6x squared minus 6x plus 3. Then substitute the 1. So x is equal to 1 also. So it's equal to 3. So after getting the first derivative, proceed to the second derivative. And then substitute x is equal to 1. And then you get this equation and is equal to 6. So after finishing the s sub 1 of x, you proceed to s sub 2 of x. So s sub 2 of x is equal to x cubed plus ax squared plus bx plus c. And then you substitute 1, or x is equal to 1. So this equation, so is equal to 1 plus a plus b plus c is equal to negative 2. And then after, you also repeat the process, get the first derivative, and then substitute the 1, or x is equal to 1, where it is 3 plus 2a plus b is equal to 3. And then after getting the first derivative, you get the second derivative, and then substitute the 1. So you get s double prime of 2 is equal to 6 plus 2a is equal to 6. So after, you have three equations. So equation 1 is 1 plus a plus b plus c is equal to negative 2. And then equation 2 is 3 plus 2a plus b is equal to 3. And then equation 3 is 6 plus 2a is equal to 6. So if we get this in calculator, for example in 991EX, you only need to press mode A1 and then 3 unknowns. So you will get a is equal to 2, b is equal to 0, and c is equal to 3. So here we have the example number 2 of cubic spline interpolation. So construct a natural cubic spline that passes through points A and 2, 2 and 3, and 3 and 5. So the first step is we get the intervals. So 1 to 2 is equal to s node double prime of x is equal to a node plus b node x minus 1 plus c node x minus 1 squared plus d node x minus 1 cubed, and 2 to 3 is equal to s sub 1 of x is equal to a1 plus b1 x minus 2 plus c1 x minus 2 squared plus d1 x minus 2 cubed. Then after getting this second interval and first interval, we already know that we have 8 unknowns. So 8 unknowns is equal to 8 conditions, and if we have 8 conditions, we have 8 equations. So here are the 8 unknowns: the A node, B node, C node, D node, A1, B1, C1, and D1. So there are 8 unknowns. So to determine the 8 unknowns, we also have 8 conditions mano. So the spline must add view with the data at the nodes. So S node double prime of x is equal to f of x, and s sub 1 of x is equal to f of x. For intervals 1 to 2, we can get it by s node double prime of x is equal to f of x. So we only have to substitute 1, or let's say x is equal to 1. So here, so we can say that S double prime node of 1 is equal to f of 1 is equal to a node is equal to 2. So we have the first equation. And then after substituting the 1, or let's say after x is equal to 1, we also get that x is equal to 2 because its interval is 1 to 2. So let's substitute 2 into this equation. Then we can get this. So a node plus b node plus c node plus d node is equal to 3. So it is our equation 2. So when we substitute the 1, we get 2. And then when we substitute 2, we get 3. So same as the interval, the next interval 2 to 3. So substitute x, which has the value of 2, to the equation. So s sub 1 of x is equal to f of x. So let's proceed to the next interval, which is 2 to 3. So substitute the 2, or let's say x is equal to 2, to this equation, or to the s sub 1 equation. And then we get 3. So this is our equation 3. After substituting the 2, let's substitute the 3 because its interval is 2 to 3. So x is equal to 3. We substitute it to the same equation. Then we get the equation 4. And then after getting or substituting the x, or the intervals, to the equation of s node and s sub 1, we get the derivatives. So the derivative of this equation is this. And the derivative of this equation is this. So after getting the first derivatives, we also get the second derivative, which is s node double prime of x is equal to 2c node plus 6d node x minus 1. Then s double prime of 1 of x is equal to 2c1 plus 6d1 x minus 2. So as we can see, equal sila. The difference only is the a node or a1 or b node b1 and their parenthesis. So this one. So equal to 2, 6. Then we get we will substitute the point 2 and 3. So x is equal to 2 and x is equal to 3. So we substitute this, and then we get this equation. So b node plus 2c node plus 3d node is equal to b1 is equation 5. And then if we substitute x is equal to 3 to s double prime node, so we get 2c node plus 6d node is equal to 2c1. So it is our equation 6. And then after, so we have 2 more equations to go because we need to get 8 equations because of the 8 unknowns. So we need 2. So let's use the natural boundary condition. So s double prime node of x is equal to s double prime of 1 of x is equal to 0. So if we substitute 1, we get 2c node is equal to 2, which is our equation 7. And if we substitute 3, we get 2c1 plus 6d1 is equal to 0. So which makes it our equation 8. So we already have completed the 8 equations. So the next is, so after getting the 8 equations, so we solve the 8 unknowns, which is the a node, b node, c node, d node, a1, b1, c1, and d1. So we can get it by inputting in calcu mode a1 for 991EX and mode 5 for 991ES calculator. So after getting the values of this, we can now say that the equation of our spline is 2 plus 3 over 4 x minus 1 plus 1/4 x minus 1 cubed, 4x is an element of interval 1 to 2, 3 plus 3 over 4 x minus 2 plus 3 over 4 x minus 2 minus 1/4 x minus 2 cubed, for x is an element of interval 2 to 3. So those two are my examples of cubic spline interpolation, and I hope you learned something. Have a good day and God bless.
Good morning, I am Eliza Michelle G. Castañas, and I am here to discuss quadratic spline interpolation. What you are seeing right now in your screen is the simplest definition of quadratic spline interpolation. Yes, it will help us smoothen our curves. Now, quadratic spline interpolation's goal is to derive an equation of second degree for each interval between the given data points. It is given as f of x is equal to ax squared plus bx plus c, or also known as the quadratic equation. Now, in every discussion, we have different goals to achieve for our listeners and understand the topic, and this is mine. So for n plus 1 number of given data points, there are n intervals and 3n unknowns constant to evaluate. I will do my best to explain in the simplest way possible what these conditions are all about. Before quadratic spline interpolation is discussed, let's recall what's linear spline interpolation first. Now, linear spline interpolation, you will just simply draw straight lines from one point to another, just simple straight connecting the dots. That's it. So here in our slide 4, given x naught, y naught all the way up to x and y sub n, it says that conduct quadratic spline interpolation. Now, what does this problem statement means? Now, it means that somebody is giving you n plus 1 data points, and what they want you to do is to develop quadratic splines through the data. So we have x naught, y naught, x1 by 1, xy 2, x sub n minus 1, y sub n minus 1, and then the last one is x sub n, y sub n. Now, as you can observe in our values of x's, they are in ascending form. So if the data is not given to you in that particular form, you just have to sort it out. Now, in quadratic spline interpolant, what we want to do is we are just going to simply draw a second order polynomial going through consecutive data points. That's their only difference sa linear interpolant. So we have this first quadratic spline. Let's call this one a sub 1 x squared plus b1 x plus c sub 1, and for the second we will call it a sub 2 x squared plus b2x plus c squared, and so on and so forth. And then we have the last one, we will call it a sub n x squared plus bnx plus c sub n. So through two consecutive data points, we can have a quadratic spline or a quadratic polynomial. So we have n plus 1 data points that is already given to us because our data points are starting from x naught, y naught all the way to x sub n, y sub n. So if we have n plus 1 data points, how many splines do we have? So we have n splines, okay? Because we have one spline going through the first and the second data point, and then another spline going through the second and third data point, and the last spline going through the last two data points. But in each quadratic splines, we have 3 unknown. So that means that we have 3n unknown. So we have to find out what the unknowns for each of the splines are. A1, B1, C1, they are all unknowns. So what to do is we've got to set up 3n equations, because if we have 3 unknowns, we need to solve 3n simultaneous linear equations so that we can find those 3n unknowns. Now we can then use our knowledge of these a's and b's to be able to calculate the value of the function at any other point, and that is what interpolation is all about. Now, in quadratic spline interpolations, naapod siya mga conditions na So we have the first one, each spline goes to 2 consecutive data points. So may meaning na. So again, let's plot the code. Okay. So that's our data points. Now here we have a sub 1 x naught squared plus b1 x naught plus c1. So those are the data points that we have. So we can see that this particular spline is going through these 2 consecutive data points, and that means a sub 1 x naught squared plus b1 x naught plus c sub 1 is always equal to y naught. And same goes with the second data point na a sub 1 x sub 1 squared plus b sub 1 x sub 1 plus c sub 1 is always equal to y sub 1. This particular spline is also going through this particular point. Now since each spline is going through 2 consecutive data, and now we have the 2n equation. So sa second one, each spline has the same slope at the interior data points. Now, remember sa linear spline, ang slope is dili parehas sa interior data. Diba? So, unsa may buhaton na to? Balik to plot. This one have our inputs. So, this is our interior data, okay? So, buhaton daw para magkaparehas ang slope sa itong interior data is kwaon ang derivative an ug kanini niya para same sila og kanang slope sa kanini na kuan interior data point. Okay? Now, let's proceed and let's separate these 2 variables and ato na sila i-derive. So, we have this one. So, ang nahitabo na ni ron, nakagama ta og equation which forces the first derivative to be the same whether mo gamit ta sa first or second spline at x is equal to x sub 1. So, the last equation na kulang sa ato ang quadratic spline interpolation is this guy right here. So, very easy to understand. So, if a sub 1 is equal to 0, so that's basically assuming daw nga ang first spline is a linear spline, no, opposing sa ato ang quadratic spline. So, we have our example here. So, the upward velocity of a rocket is given as function of time. Now, using quadratic splines, we are told to find this. So, we have to find the velocity, acceleration, and the distance. Now, this is our given, and let's go and plot them. So, we have x as the time, and then the velocity as our y. So, we have the first one, 0, 0, and then 10, 2, 2, 7, 15, 362, 20, 517, 22.5, and 602.97, and then we have 30, 901.65. We have 1, 2, 3, 4, 5 splines sa 6 kabuo data points. So these are the 5 consecutive quadratic splines I was talking about, and each spline will be a quadratic equation. So we have to remember na naatay tulo ka unknowns sa kada spline. So we have 15 unknowns all in all, because we have 5 splines going through the 6 consecutive data points, and each spline has 3 unknowns. Let's go ahead and set up this 15 equation and 15 unknowns. So divide each spline will you have to go through data points. Now again, let's recall. So my first spline is this one. Yeah. Now let's go ahead and set up those 10 equations. So this equation right here, these are coming from this spline, no? And then same also this one. So bali plug in ragid mo guys ang mga variable tayo. 22, 5, 22, and 30. So we now have 10 equations. No? So asa man nato ang tawag 5. So nakainom dumra karang bell. Derivatives are continuous at interior points, data points. Ato ang ikuan ba? I-derive ang kaning duha para same sila og slope. Diba? May takas kung ano sa mga point ang gamiton, same slope nga kanang at so kani kailangan nato i-derive this goes right here. Ano siya? This one. So separate na nato. Diretso na nato guys. So naman siya ang kuha na to sa pag-derive ang duha na ayan. So dara ang ubang points, ubang data points. So notice guys, may missing patras sila. So si 0 o si 30 wala man sila diri para 30 data points only. 0 and 30 are external data points. So diba na naman tayo 10 equations, and then we got 4 because derivatives are continuous at interior data points. Now ang last equation na to is this guy right here. See a sub 1 t squared b sub 1 t plus 1. So pag masolve na nato ang 15 equations and unknowns, mga siya ang mga resulting coefficients na nato ang makuha. Okay? Oh wow, drama. What a transition. Okay. So these are the 5 splines that we get, okay? So notice asa ato ang first na manulahi siya sa ubang equation. Linear spline siya. So anong lahi daw siya sa tuopat? It's because ni-assume ba yata nga a sub 1 is equal to 0, diba? So ano siyang nadiri na ta sa pag-kuhan sa problem, pag-solve dun sa problem. So ana siya ng velocity ko no at tayo 16. Now of course ang ato ang gamiton ani na equation is this guy. Nakahiwi no na naman rearrange man niya sa 16. Dili ta matug 10, 15, dili ta matug 20, 25 lang sa 16 dito. So gamiton na lang siya nato, plug in 16 and our answer is yun. So here is our answer. Okay. So, ari na ta sa ikaduha nga gipangayo, which is the acceleration at time 16. So, di-copy-paste na ito ang mga splines, no? And then, we have this formula, A16 is equal to derivative of volume times time, t is equal to 16. Oops, nalagyan yung answer. Oh, sana ako na siya skip kasi nakita mo yung answer. So, yun na nga, dire, the quadratic spline valid at time is equal to 16. So, ano na siya guys? Hindi na siya pag-derive. And then we got our final answer. Ito ang answer. Okay? So, the last one, no? Lagi pa nga sa problem. Find the distance covered by the rocket from time 11 seconds and 16. Okay, so na-plug in natin ulit yung ating 5 splines kasi I forgot to paste it. So, yun. Ang ipangita sa last problem is ang distance na covered ni rocket sa time 11 seconds and 16 seconds. So, saan naman ito na? So, we have 10 and 15, the 15 and 20. So, sila, kaning duha, covered sa ato ang range ng 11, 16. And then, and this one. Okay, so we have one spline between 10 and 15 and the other spline na valid kay si kuan sa 15 and 20. So, kalagi 11 to spline so kailangan na to gamiton ang duha. So, muna na ito. This guy is right here. Ayan. So, maunang nakakuha ta o 1,595.5 meter. Now, before mag-end ang ako ang discussion na ako ipakita ninyo na video na akong nakitaan sa YouTube which kanang interesting siya kasi program na side siya sa Quadratic Spline, but I will not do a tutorial something on how the program was kanang made, but like kanang ato lang sa part nga iyan ang gi-plot ang mga data points and then nag-compare siya sa linear and sa linear and sa quadratic na mga outputs sa MATLAB. So MATLAB yung gamit. So let's go ahead and watch it.
As I step through here, you'll see a spline added. So again, here is my first linear spline that we assumed, and then here's my second spline, and notice here that rather than just going linear between them, I make this nice quadratic, and then every time I step through here, I add an extra quadratic spline, and at the end of the day, and I think I add a legend here, at the end of the day you get this nice curve. And so basically we started with our blue stars, which was our measured data, which had made no sense whatsoever, and then we connected the dots with linear splines, and we didn't really like that very much, and then now we have quadratic splines, and now we have a nice smooth curve here.
Good day, everyone. We are the next reporter, and our topic is about the curve fitting by function approximation. My name is Jewel Lunaria, and I am here with Leia Tadlas for this discussion. But before that, let us define first what is curve fitting. Curve fitting is the process of constructing a curve or mathematical function that has the best fit to a series of data points, possibly subject to constraints. Can involve either interpolation, where an exact fit to the data is required, or smoothing, in which the smooth function is constructed that approximately fits the data.
Fitted curves can be used as an aid for data visualization to infer values of a function where no data are available, and to summarize the relationship among two or more variables. Finding an analytical function which approximates a set of data points. Statics can quantify the relationship between the fifth errors in data points. Example for this is experiment.
It is also concerned with the calculation of the fitting curve itself. Capturing the trend in the data by assigning a single function across the entire range. It also finds the solution to the overdetermined system that is closest to the data.
Next is function approximation. Approximation is anything that is similar but not exactly equal to something else. Ask us to select a function among a well-defined class that closely matches a target function in a task-specific way.
For known targets, function approximation theory is a branch of numerical analysis that investigates how certain known functions, for example, the special functions, which can be approximated by a specific class of functions. Another example, we have the polynomials or rational functions that is often have desirable properties. Another example or other examples, we have the inexpensive computation, continuity, integral, limit values, and etc.
Let us come now to the main topic of our report, which is the curve fitting by function approximation, which we have here two subtopics, the norm approximation and the least norm problems.
First is norm approximation. What is norm? Norm is a function from a real or complex vector space to the non-negative real numbers. Zero only from the origin. Euclidean norm. It gives the ordinary distance from the origin to the point xa, consequence of Pythagorean theorem, which also denoted as SRSS, which is square root of the sum of squares. And this is the symbol of norm. And this is the symbol of Euclidean norm, which also can be read as 2 norm. Minimize norm ax minus b. Interpretation of solution x star equals argument minimum x norm ax minus b. In terms of geometric, ax star is point in R times a closest to b. And in terms of estimation, linear measurement model, y equals ax plus v, where y are measurements, x is unknown, v is measurement error, given y equals b, best guess of x is x star. And in terms of optimal design, x are design variables, which is input, ax is result, which is output, x star is design that best approximates desired result b. And this is the example of how to solve norm approximation using least square approximation, which least square approximation is the solution satisfy normal equation, which A transpose AX equals A transpose B. And here is the video which explain on how to solve norm approximation using least square approximation. Please watch and listen.
Let's find the least squares approximating line for the following set of 4 points. Well, this least squares approximating line, it's sometimes called the least squares regression line. It's going to have a formula that looks like this. Y will be equal to some constant plus some coefficient times x. Now what we'd like to do is write this in the form of a system that we can solve. And in thinking about this system, it's important to remember that the unknowns here are actually this constant and this coefficient. So it's A0 and A1 that we're ultimately trying to find. And those are playing the role that X normally plays when we're solving a system. So in thinking about how to set up the system then, let's look at this equation here and see if we can rewrite it a little bit differently. Looking at the right side, we could write it as 1 times A0 plus X times A1, and we could say that's equal to Y. So that will give us a little prompt here in terms of how to write out this system. If our A0 and A1 are over here, then we're going to need 1 to multiply with the A0, X to multiply with the A1. So that tells us how to fill in these columns here. And we want that to be equal to Y over on the right side. All right, so the first column here on the left side is just going to represent a column of ones. And beside that, we're going to fill in our different X values that were given in our set of points in the problem. So the X values were 1, 2, 5, 6. All right, and then over on the right side, we're going to fill in our Y values from the given set of points. So that would be 3, 4, 5, 10. Now this system, as we've written it, may not have a solution. In general, any system AX equal B may not have a solution. But if we multiply both sides of this equation by A transpose, and we get A transpose AX equals A transpose B, then this will have a solution. Let's say it has a solution, but there are a couple of comments I want to make here. So first of all, in writing this, it really would be a good idea to rename our X rather than just call it X as we did before. Let's give it a special name like X star, because it's not necessarily the same X as we wrote in the previous line. Remember, the solution, the system AX equal B may not even have a solution. X star here represents what's called this least squares solution to the modified system. And then just a technical condition here, this modified system will have a solution when the columns of A are linearly independent. So this gives us a hint as to how to find our least squares solution, X star. If we could multiply both sides by the inverse of A transpose A, then we would have isolated X star. So let's write X star is equal to A transpose A inverse times A transpose B, and that gives us the formula that we're going to get started with. From the previous screen, I've just recopied the system that we set up at the beginning of the problem, and I've recopied our formula for the least squares solution X star. So let's work towards finding X star. First thing I would probably do is work out what A transpose A looks like. A just refers to this coefficient matrix up here in our system. So if we transpose that, we get 1s along the top row, and then 1, 2, 5, 6 along the bottom row, and that's going to get multiplied by the original matrix A. So doing that matrix multiplication, we end up with a 2 by 2 matrix, which looks like 4, 14, 14, 66. Now we can find the inverse of this matrix using the formula for 2 by 2 inverse. We are going to swap the entries on the diagonal, change the sign of the off-diagonal entries, and we'll divide by the determinant of that original matrix, which is 68. So there we have the formula for our inverse. Now let's go back to our formula for X star, and we'll start putting all the pieces together. We'll have to take this inverse that we've just found, multiply it by A transpose, and then by b, which in this problem is the vector which contains our constants over on the right side. All right, so this is going to look like 1 over 68 times this little 2 by 2 matrix times A transpose times the matrix B, which is the one that records our y values. And we can think about multiplying this out. Now, in terms of efficiency, it probably makes sense to multiply these guys together first. It's just going to turn into a shorter calculation that way, or smaller matrices to write down. So it might save a little bit of time from that perspective. If we multiply through, we are going to get the matrix 22, 96. And I think I'll leave this 1 over 68 out in front for now and just do this last multiplication here. We're going to get 108 and 76. Now, if we look at our coefficients here, 108, 76, as well as 68, those are all divisible by 4. So we may want to actually simplify these fractions a little bit. Instead of writing 108 over 68, we might want to write 27 over 17 and 19 over 17 for the second coefficient here. Okay, now going back to our original system, remember these represented the values of A0 and A1. And our line had the form y equals A0 plus A1x. So meaning the line that we're looking for is y equals 27 over 17 plus 19 over 17 times x. That is our least squares approximating line for those 4 given points.
Hi and welcome. Today we're going to do a problem about least squares approximations. Here's the question. Find the quadratic equation through the origin that is a best fit for these 3 points, 1, 1, 2, 5, and -1, -2. I'll give you a minute to work that out on your own. You can hit the pause button now, and we'll be back in a minute to work the problem out together. Okay, and we're back. So what's the first step in a problem like this? The first step is figuring out what our equation looks like, the one that we're going to find. So our equation is going to look like ct plus dt squared equals y. So that's what we're looking for. We're looking for a quadratic equation through the origin. Now, if it were just any quadratic equation, then we would have a constant term, but through the origin just means that the constant term is 0. Okay, now, what's the next step? Next, we need to set up a matrix equation. So we need an A, a matrix A, and which matrix is that going to be? Well, let me start with the first coordinate of these 3 points, and I'm going to put them in the first column of this matrix, 1, 2, -1, and then my second column is going to be the squares of these first coordinates, 1, 4, and 1. And my x hat, that's just C and D, and my B, this is going to be the second coordinates, 1, 5, and -2. Okay, why did I set this problem up like that? Well, multiply A times x hat. Okay, the first coordinate of A times x hat is 1 times C plus 1 times D. it's just the same as plugging in this first point into the left-hand side of this equation. Okay, and similarly, if I took the second point and plugged it in here, I would just get 2 times c plus 4 times d, which is just the same as the second coordinate in the multiplication a times x hat. 2 times c plus 4 times d. Okay, and where did the b come from? Well, the b came from plugging in these points to the right-hand side. So 1, 5, and negative 2 are just the y coordinates of these 3 points. Good. So it would be great if we could solve ax hat equals b, but we can't solve ax hat equals b because there isn't a quadratic equation through the origin that contains these 3 points. But we need to find the best approximation to that. So that's the same as solving ax hat equals the projection of b onto the column space of A. Because we only have a chance of solving ax hat equals something if it's in the column space of A. And remember from our projections part of the class that this is the same as solving A transpose A x hat equals A transpose B. Good. So that's what we're really going to do. We're really going to solve A transpose A x hat equals A transpose B. And now all we have to do is just a computation. So let's do it. So what is A transpose A? I'm going to do this kind of quickly because you should be good at multiplying matrices by now. Yeah, sorry. I have the negative in the wrong place. Thank you. Thanks for that correction. I had the negative backwards there. Good. Okay, and what do I get when I multiply these? I'll let you check that this is 6, 8, 8, and a 10. Okay. And what is A transpose B? Well, if you multiply this out, I'll let you check that you get 13 and a 19. Good. So this is just some computation. And so what we're solving here is 6, 8, 8, 10 times x hat equals 13, 19. And we remember how to do this just by using elimination. We replace the second row by 3 times the second row minus 4 times the first row. Again, I'm going to do this quickly because you know this from other parts of the class. You similarly change the b vector, and we back solve to get d is -5 halves, and c equals, let's plug that in c, I think you're going to get 11 over 2. So what's our final equation? Our final equation is y equals 11 halves t minus 5 halves t squared. Good. Okay, so this is our best fit quadratic equation through the origin. Now, before I end, let me do a couple things. First, let me go back and review what the key steps were. Whenever you're faced with such a best fit equation, first you want to see what the general form of the equation is. Next, you want to write it in terms of matrices. Write down your matrix A and your vector B. And lastly, you set up your projection equation. And then all you have to do is just a computation. Good. It might also be worth noting that these 3 points certainly aren't on this quadratic equation. For instance, if I plug in 1 here, I don't get 1, 1, I get 1, 3. But that's okay. This is as close as we can do. Thanks.
Next, we have the least norm problems. First one is I'm going to introduce to you the undetermined and the overdetermined equation. Then we have an example of the least norm solution using the Moore-Penrose pseudo-inverse, which is that the Moore-Penrose pseudo-inverse will be tackled along the introduction of the undetermined and the overdetermined equations. First, we have here the undetermined equation, which is, we will call it as a short fat matrix A, which is that it stated that n is less than m, or the number of rows is less than to the number of the columns in the matrix. We have here a diagram to explain the underdetermined equation. First, we have here the short or the fat A matrix, then multiplied by a tall x vector is equal to the short B vector. So this generally is called the underdetermined because there is not enough measurements in our vector B to uniquely determine a single unique solution of x. And this denotes that there will be infinitely many solutions of x given B because there are kind of more unknowns than the known values. Next one, we have the overdetermined equation, or we will call it as the tall skinny matrix A, which states that n is greater than m, or the number of rows is greater than the number of columns. Here we have a diagram to explain the overdetermined equation. The first one, we have the A matrix, which is the tall or skinny A matrix, then multiplied by the short x vector, and is equal to the tall B vector. In this case, there are more equations than there are unknown values in x. Then, in general, there will be 0 solutions of x for a generic B vector, because there are not enough degrees of freedom in x to fit all of these equations in general. Now, let us compare the two equations, which is the underdetermined equation and the overdetermined equation. In the case of the underdetermined equation, mas dagan ang iya x values, or which is our unknown values, compare sa mga known values given B, which results to many solutions. While ang sa overdetermined kay nigamay ang unknown compare sa mga known values, which it will result to no solutions. Pero ang kani siya na case kay di ni siya always true. Now let us give an example where the previous examples, the overdetermined and the underdetermined equations, were not true. Now the singular value decomposition, or the SVD, is going to allow us to do an approximation, or to approximately invert the A matrix to compute what is known as the pseudo-inverse and find a best fit x that either comes as close to solving this as possible, or solving this equation with the minimum 2 norms of the vector of x. Now let us assume that we have a matrix. What will I do here is that I will take a singular value decomposition, or which is the SVD. So I have here the U sigma V transpose. What can we define in this equation is the A plus, or we will call it as the A dagger, or the pseudo-inverse of A, which is called the Moore-Penrose pseudo-inverse. Now we have an equation of A is equals to U sigma V transpose is to A dagger. Now let us use our previous equation, which is the AX is equal to B. Then we're going to substitute the value of A, which is equal to U sigma V transpose to our equation, which is the AX equals to B. Now, we will have the U sigma V transpose times X is equal to B. Then what we're going to do here is to try to invert the U sigma V transpose or the value of A. Then to do that, we will multiply both equation or both side of the equation with the U transpose, the inverse sigma, and V to cancel out the U sigma V transpose. Next, we will distribute the equation. Now we will have the U sigma V transpose times the U transpose inverse sigma times V times X, which is nani siya X din sa left side, is equal to B times the U transpose inverse sigma times V. So ang kaniyang U sigma V transpose is makancel out na ni, so bali X na lang ang mabilin sa tong left side. Now we will have X is equal to U sigma inverse U transpose times B, or ang kanisya na U sigma inverse U transpose is mo na siya atong tawag na katong A dagger, mo na siya ang A dagger. Then kaning this equation, the X is equals to A dagger times B, is ang kaning X is i-denote lang nato as X tel D. Kay mao ni siya ang mo approximately mo pangita sa value sa atong unknowns. Then ang atong final na equation kay we have the A is equals to U sigma V transpose to A dagger is equals to V inverse sigma times U transpose. Ang kaniyang value sa A dagger is mo ni atong gitawag na Moore-Penrose pseudo-inverse. Since a proper inverse doesn't exist and this equation is the closest to inverting the A matrix and solving for our unknown value, which is the X, we have now the final equation. I will call this as the X tel D, which is we have now the final equation of X tel D is equals to A dagger times B. So this X tel D or this X is somehow the best X values or value that we're going to get for our underdetermined and overdetermined equations of linear system. Is specifically the equation we get, which is our approximation equation, which we denote as the X tel D, which is equal to A dagger times B, or X tel D, which is ang value sa tong A dagger, mo man to ang U inverse sigma U transpose. Tapos, on the case of underdetermined equation, which we have infinite many solutions, right? Then this X tel D have the minimum of two norms. We will write it like this. So the minimum two norms of X tel D such that A X tel D is equals to B. So this state that A X tel D is equal to B. So of all infinitely many X tel D that do in fact satisfy the A dagger is the solution that has the minimum two norms. So this equation, we will call this as the minimum norm solution. In the case of the overdetermined case, which we have no solutions, the A dagger or the Moore-Penrose pseudo-inverse, from this we will get the least square solution. So this least square solution, which will minimize the error between the AX tel D and the B. So these two norm errors, so kaniyang equation, the minimum two norms of ax tilde minus b. So this is called the least square solution. So even we cannot find the x that a times x equals b, this equation, the minimum two norms of ax tilde minus b will minimize the error. Kaning i-review lang to balik atong last topic sa katong about sa kaning vector and matrix algebra is specifically ang eigenvalues and eigenvectors ang iyang thought. We have here a video example of solving the least norm problems using the Moore-Penrose pseudo-inverse. So please watch it and listen carefully.
Hi everyone, welcome back. So today I'd like to tackle a problem on pseudo-inverses. So given a matrix A, which is not square, so it's just 1 and 2, first, what is its pseudo-inverse? So A plus, I'm using to denote the pseudo-inverse. Then secondly, compute A plus A and A plus. And then thirdly, if X is in the null space of A, what is A plus A acting on X? And lastly, if X is in the column space of A transpose, what is A plus A X? So I'll let you think about this problem for a bit, and I'll be back in a second. Hi everyone, welcome back. Okay, so let's take a look at this problem. Now first off, what is a pseudo-inverse? Well, we define the pseudo-inverse using the SVD. So in actuality, this is nothing new. Now we note that because A is not square, the regular inverse of A doesn't necessarily exist. However, we do know that the SVD exists for every matrix A, whether it's rectangular or not, or sorry, whether it's square or not. So how do we compute the SVD of a matrix? Well, let's just recall that the SVD of a matrix has the form of U sigma V transpose, where U and V are orthogonal matrices, and sigma is a matrix with positive values along the diagonal, or zeros along the diagonal. And let's just take a look at the dimensions of these matrices for a second. So we know that A is a 1×2 matrix. And the way to figure out what the dimensions of these matrices are, I usually always start with the center matrix, sigma. And sigma is always going to have the same dimensions as A, so it's going to be a 1×2 matrix. U and V are always square matrices. So to make this multiplication work out, we need V to have 2, and because it's square, it has to be 2×2. And likewise, U has to be 1×1. So we now have the dimensions of U, sigma, and V. And note, because U is a 1×1 matrix, the only orthogonal 1×1 matrix is just 1. So U, we already know, is just going to be the matrix, the identity matrix, which is a 1×1 matrix. Okay, now how do we compute V and sigma? Well, we can take A transpose in A, and if we do that, we end up getting the matrix V, sigma, transpose, sigma, V transpose. And this matrix is going to be a square matrix where the diagonal elements are squares of the singular values. So computing V and the values along sigma just boil down to diagonalizing A transpose A. So what is A transpose A? Well, in our case, it's 1, 2 times 1, 2, which gives us 1, 2, 2, 4. And note that the second row is just a constant multiple times the first row. Now what this means is we have a 0 eigenvalue. So we already know that lambda 1 is going to be 0. So one of the eigenvalues of this matrix is 0. And of course when we square root it, this is going to give us a singular value sigma, which is also 0. And this is generally a case when we have a sigma which is not square. We typically always have 0 singular values. Now to compute the second eigenvalue, well, we already know how to compute the eigenvalues of a matrix, so I'm just going to tell you what it is. The second one is lambda is 5. And if we just take a quick look, what the corresponding eigenvector is going to be to lambda is 5, it's going to satisfy this equation. So we can take the eigenvector u to be 1 and 2. However, remember that when we compute the eigenvectors for this orthogonal matrix V, they always have to have a unit length. And this vector right now doesn't have a unit length. We have to divide by the length of this vector, which in our case is 1 over root 5. And if I go back to the lambda equals 0 case, we also have another eigenvector, which I'll just state. You can actually compute it quite quickly just by noting that it has to be orthogonal to this eigenvector, 2 and 1. Okay? So what this means is A has a singular value decomposition, which looks like 1, so this is u, times sigma, which is going to be root 5, 0. Remember that the first sigma is actually the square root of the eigenvalue, times a matrix which looks like, now we have to order the eigenvalues up in the correct order. Because 5 appears in the first column, we have to take this vector to be in the first column as well. So this is 1 over root 5. This is 2 over root 5. Negative 2 over root 5. And 1 over root 5. And now this is V, but the singular value is V. The singular value decomposition is defined by V transpose. Okay, so this gives us a representation for A. And now once we have the SVD of A, how do we actually compute A plus, or the pseudo-inverse of A? Well, just note, if A was invertible, then the inverse of A in terms of the SVD would be V transpose times the inverse of sigma. Oh, sorry, this is not V transpose, this is just V. So it'd be V sigma inverse U transpose. And when A is invertible, sigma inverse exists. So in our case, sigma inverse doesn't necessarily exist because sigma, note this is sigma, sigma is root 5 and 0. So we have to construct a pseudo-inverse for sigma. So the way that we do that is we take 1 over each singular value, and we take the transpose of sigma. So when A is not invertible, we can still construct a pseudo-inverse by taking V sigma, an approximation for sigma inverse, which in our case is going to be 1 over the singular value and 0. So note how where sigma is invertible, we take the inverse, and then we fill in zeros in the other areas, times U transposed. And we can work this out. we get 1 over root 5, 1 minus 2, 2, 1, 1 over root 5, 0. And if I multiply things out, I get 1/5, 1, 2. Okay, so this is an approximation for A inverse, which is the pseudo-inverse. Okay, so this finishes up part 1, and I'll start on part 2 in a second. Okay, so now that we've just computed A plus, the pseudo-inverse of A, we're going to investigate some properties of the pseudo-inverse. Okay, so for part 2, we need to compute A times A plus and A plus times A. Okay, so we can just go ahead and do this. So A plus, we can do fairly quickly, 1/5, 1, 2. And when we multiply it out, we get 1 plus 4 divided by 5 is 1. So we just get the 1 by 1 matrix, which is 1, the identity matrix. And secondly, if we take A plus times A, we're going to get 1/5, 1, 2, times 1, 2. And we can just fill in this matrix, which is 1/5, 1, 2, 2, 1. Okay. And this concludes part 2. So now let's take a look at what happens when a vector x is in the null space of A, and then secondly, what happens when x is in the column space of A transpose. So for part 3, let's assume x is in the null space of A. Well, what's the null space of A? We can quickly check that the null space of A is a constant times any vector minus 2, 1. Okay, so that's the null space. So if x is, for example, i.e., if we take x is equal to minus 2, 1, and we were to say multiply it by A plus A, acting on x, we see that we get 0. And this isn't very surprising because, well, if x is in the null space of A, we know that A acting on x is going to be 0. So that no matter what matrix A plus is, when we multiply by 0, we'll always end up with 0. Okay, and then lastly, let's take a look at the column space of A transpose. Well, A transpose is 1, 2, so it's any constant times the vector 1, 2. And specifically, if we were to take, say, x is equal to 1, 2, we can work out A plus A acting on the vector 1, 2. So we have 1/5, 1, 2, 2, 1. So recall this is A plus A. And if we multiply it on the vector 1, 2, we get 1 plus 4 is 5, divided by 5, so we get 1. 2 plus 2 is 4. Oh, sorry, I copied the matrix down. So it's 2 plus 8, which is 10, divided by 5 is 2. And we see that at the end, we recover the vector x. So in general, if we take A plus A acting on x, where x is in the column space of A transpose, we always recover x at the end of the day. So intuitively, what does this matrix A plus A do? Well, if x is in the null space of A, it just kills it. We just get 0. If x is not in the null space of A, then we just get x back. So it's essentially the identity matrix acting on x whenever x is in the column space of A transpose. Now specifically, if A is invertible, then A doesn't have a null space. So what that means is when A is invertible, A plus A recovers the identity because when we multiply it on any vector, we get that vector back. Okay, so I'd like to conclude here, and I'll see you next time.
So that ends our report about the curve fitting by function approximation.
Good day everyone, I am Aldin Luengo. I am going to report my assigned topic, which is curve fitting using least square method. The least square method provides the overall rationale for the placement of the line of best fit among the data points being studied. Using the least square method will generate a line of the best fit that explains the potential relationship between independent and dependent variables. The dependent variables are illustrated on vertical y-axis, while independent variables are illustrated on horizontal x-axis. These designations will form the equation for the line of best fit, which is determined from the least square method. And what is least square method used for? The least square method is a statistical procedure to find the best fit for a set of data points by minimizing the sum of the offsets or residuals of the points from the plotted curve. Least squares regression is used to predict the behavior of dependent variables. So, least square method is we can solve the required equation to predict the dependent variables. And there are 3 equations that we might use in the curve fitting using least square method. First is the straight line, second is the exponential functions, third is the parabola. And today I am going to tackle about the straight line and the exponential functions. And this is the sample problem of a straight line curve fitting. Bob found how many hours of sunshine versus how many ice creams were sold at the shop from the Monday to Friday. These are the data that Bob found. Hours of sunshine and ice cream sold. Hours of sunshine is our independent variables and ice cream sold is our dependent variables. And solving the required equations, these are the steps that we are going to make. First, we need the equation of a straight line, which is y equals a plus bx, where our a is the y-intercept and our b is our slope. So these 2 equations is very important in least square method. These 2 equations is very important in least square method because in the exponential function or in the parabola, these 2 equations is also used. Same concept with the straight line. So after we have the the two normal equations, we need to find the unknowns on the equations 1 and equation 2. First, based on the plotted or based on the presented data, which is our dependent and independent variables, we can solve the x squared and xy. So after this, we sum up all the values in the dependent and independent variables and the x squared and the xy, which is we have 26, we have 26, we have 31, we have 168, and we have 263 for the xy. And after we have all the summations, we are going to substitute them on our normal equation, which is this one and this one. So our summation of y is equals to 41, and our n, and by the way, the n is the number of data points presented in the graph, where we have 1, 2, 3, 4, 5. So our n is 5. Then our summation of x is equals to 26. Then our value of summation of xy is equals to 263. And our value of summation of x is 26, and the value of summation of x squared is 168. So to solve the values in the equation of a straight line, which is y is equals to a plus bx, we can solve the value of a and the value of b by using the two equation to unknowns. In this method, I am going to use my calculator, my scientific calculator, mode 5.1, which is two equation to unknowns. I plotted the coefficient of the unknown variables, which is in equation 3 is the coefficient of a is 5, and the coefficient of b is 26, and the constant is equals to 41. And the equation 4 is coefficient of a is 26, and the coefficient of b is 168, and the constant is 263. Afterwards, when you press the equal sign in your calculator, the first value is our value of a, which is 25 over 82, or 0.38049. And when we press again the equal sign, we have our value of b, which is 249 over 164 is equals to, or equals to 1.5183. So by plotting, by substitution on the equation of a straight line, which is y equals a plus bx, we can have our required equation of a straight line, which is y is equals to 0.3049 plus 1.5183x. This is our required equation. And after that, when we use the equation, the required equation, and the value of our independent variables, we have 3.34. We have 3.34 for the value of 2, and the value of our independent variable, which is 3, we have 4.86. The value of 5, we have 7.89. The value of 7 is 10.93, and 9 is 13.86. 97. Based on the data, which is our y is 4 and our y is 5, 7, 10, 15, we can minimize the error. Just we have an error of negative 0.66, negative 0.14, negative 0.89, negative 0.93, negative 1.08. So this is the layout of error. The error is the vertical distance from the line, which is the line we make to close all the data points, to close it together as possible. So those vertical distance from the line and the data points, which is our error. So in our simple problem number 1, Bob hears the weather forecast, which says we expect 8 hours of sunshine tomorrow. So he uses the required equation to estimate that how much ice cream he will sell. So based on the news that the weather forecast, that they say that 8 hours of sunshine, Bob substitute the value of x to 8, which we can predict the value of dependent variable is equals to 12.45 ice creams. So if it is true that tomorrow there is 8 hours of sunshine, Bob can sell an ice cream of 12.45 ice cream. So Bob made a fresh waffle cone mixtures for 14 ice creams, just in case, because these estimations of this discount method is we can predict the dependent variable based on the dependent variables, or the relationship between dependent and independent variables. So now I am going to tackle the exponential function. I also have one example of exponential function. Find the curve of the best fit equation of y equals aebx to the following data using method of least square. So this is our data. This is our presented data, which is our dependent variables is 10, 15, 12, 15, 21. And our independent variable is 1, 5, 7, 9, 12. As you can see, the values of independent variables is not in linear form, or some of it become bigger, or some of it again smaller and again bigger, like 10, 15, 12, 15, 21. So this data, or in a graph, the behavior of this data on a graph is not showing relationship or linear relationship. That's why you cannot use the straight line, because the trend of the data is not showing linear relationship. So the best equation that you use is exponential function. So this is the process or the steps in solving the exponential functions. So same with the straight line, that we're still using the two normal equations, this one, we still use the two normal equations, same concept with the straight line. So y is equals to a times e raised to bx. So in this case, we multiply both sides by log. So log y, and this there is the identity for a property of log, which is in this case we have product property. So the property of a product in a log is equals to log AB equals to log A plus log B. So that's why in our equation we have log y equals to log A plus log E bx. And after this one, we can also derive the equation into this. Log y equals to log A plus bx log E. So we also have the identities of logarithm, which is log x raised to the power, which is we need to go down the power, the p log x. So that's why the bx become the coefficient in log A. So in this case, the log y is equals to big letter y, and the log A represents the big letter A, and the bx log E represents the bx. So same concept with the normal equations. And based on the data presented in the problem, the dependent and independent variable, which is 15795, and the dependent variable is the 10, 15, 12, 15, 21. We can solve the y, the big letter y, which is the equals to log y. So this is the only difference, the difference between the straight line, because straight line you just simply computing the summation of x squared, summation of xy. But in the exponential form, we need to find the value of big letter y, which is represented as log y. So to solve the value in big letter y, you need to use on your calculator and just find the log on the scientific calculator, then press the value of the dependent variable, which is 10. So in your calculator, you need to input this one, log 10. Yeah, log 10. So when you press the equal sign in your calculator, it will come out to 1. So same process with the other data points, which is log 15 is equals to 1.18 and so on. So afterwards, you need to find the summation of x squared, which is the square root of 1 is 1, square root of 5 is 25, square root of 7 is 51, square root of 9 is 81, square root of 12 is 145. And the summation of xy, which is first solve the xy, x multiply the dependent and independent variable, which is I mean the big letter y, which is the log y. So 1 times 1 equals 1, 5 times 1.18 is equals to 5.9, 7 times 1.08 is equals to 7.56, 9 times 1.18 is equals to 10.62, and 12 times 1.32 is equals to 15.84. So after it, add all the values of independent variables, add all the values of big letter y, which is the log y, and add all the values of x squared, all the values of x times big letter y. So if we already have the values, on the unknown equation, which is the summation of y and n, a plus b summation of x, we can now substitute it to our equations, this one. So the value of our summation of y is 5.76, and the value of our n is 5, since we have 5 data points, and our value of summation of x, which is 34. That's why we have 34 here. So in the second equation, the value of summation of x times big letter y, which is this one, the 5.76, we have 40 summation of xy, which is 40.92, this one. This one, we have the summation of xy is equals to 40.92, and our summation of x is 34, and our summation of x squared is 300. So after this, same concept or process with a straight line, which is the two unknowns, to find the value of big letter A and big letter B. And remember, this is the big letter A and big letter B, which is logarithm. So to find the value of A and B, just go to mode 5.1 and input all the coefficients of the variables, which is, we have the value of A is 5, value of B is 34, coefficient value of A is 34, coefficient value of B, and the constant of the two equation is 5.76 and 40.92. You press the equal sign in your calculator. The first value that come out is 0.9788, which is the value of A, big letter A. And when you press again the equal sign on your calculator, the value of B is equals to 0.0255. So this is not the final value on our equation of exponential, because this is involves big letter A is equals to log A. And to find the value of small letter A based on our exponential equation, which is y equals small letter a times e raised to bx, you need to find the anti-lag, which is also solved in calculator. You find the shift lag, and anti-lag is shift lag. So shift lag, input the value of a 0.9788, you have a value of small letter a to 9.55. And same with the big letter b, which is log e b is equals to big letter b. So same with log a. Go to your calculator, press shift log, then input the value of b, which is 0.255, and equals to 1.06. So now you can have the value of your required equation on exponential form, which is y equals to a raised to y equals to a times e raised to bx, where your a is equals to 9.5, and the value of your b is 1.06, then your x is your the value of your dependent variable to predict the value of independent variable. In these equations, it just shows the relationship between the dependent and the independent variables. So, and the equation of parabola, one of my group members will discuss. Thank you.
Oh, hello guys, this is Cornelius Aldrano, and today I'll be talking about least square fit using parabola. So, least square fit using parabola usually talks about kani siya quadratic parabola or second degree curve. So, ako na siya ikaw na. So, mani siya guys, atong gamiton. So, quadratic parabola na siya equation guys. So, ano sa may equation niya? So, yung equation equals to y equals to a plus bx plus cx square. So, muna siya guys. Anya, kung ato na siya kung ano guys, tan-an guys, nailaing mga topic about least square feet. Ubang topic nag-talk about straight line. Sunod na quadratic parabola. Second na cubic equation. Last is exponential equation. So, ano siya topic guys nga naa sa least square feet. So, kung talk ta about straight line guys, yung equation guys kay y equals to a plus bx. Muna na siya guys ang quadratic parabola na sa taas. Ako lang i-copy guys. Ano? Sorry. Ito na siya i-copy. Ano siya guys ang atong quadratic parabola. Sa least square feet guys, ang least square feet, ang equation equals to y equals to a plus bx plus cx square plus dx cube. Ano siya guys. Ang exponential equation guys, na siya tulo ka equation. Ang first equation guys equals to y equals to a times e times b to the power of x. Second equation niya kay a times b to the power of x. Last equation guys equals to a times x to the power of b. So, mananay siya guys ang mga equations guys nga gamito na to sa least square feet. Pero sa kaning topic guys, gamito na ko ang equation sa parabola. So, kanya siya copy ha. Tarong mo na to ang 2. So, ato na siya i-expand yung equation guys. So, ini-expand na to ani guys kay ato na siya gamitan og summation. So, summation of y equals to an plus b summation of x plus c summation of x square. So, na guys, i-expand na siya dato na siya. So, summation of xy equals to a summation of x plus b summation of x square plus c summation of x cube. Ang pinaka-last nga summation guys. So, last summation. So, x square y equals to a summation of x square plus b summation of x cube plus c summation of x to the power of 4. So, manini siya guys at ang gamiton guys nga equation for makasolve ta sa problem using a quadratic parabola. So, ato na siya i-copy guys. Let's try to solve a problem. So, guys. So, calculate fitting a second degree curve. So, kung may tag second degree curve, ano ni siya? Mani siya second degree curve guys. Mani siya iyahang mga summations. Mani siya. Gamiton natin ni siya guys para makasolve ta siya mga unknowns. So, siya sa atong structural guys, magamit og mode 5.1 o mode 5.2 para makasolve ta sa mga unknowns niya. Muna ni siya guys ang mga given nga mga values nga dapat nimo i-solve. So, kung tan-awin nimo guys, 1, 2, 3, 4, 5. So, imong n na guys is equals to 5. Ato na siya i-expand guys ha. Ato na siya ibutang sa ubos. Ato na siya i-copy. Tang sa ubos. Lang. So, magbutang na sa another table asad. Kung magbutang tag gamay nga table. So, gamay nga x, i-minus nimo sa dako nga x, ang gamay nga x is equals to dako nga x minus nimo sa kaning total ani. Total ani. So ato na siya i-solve guys. So mali siya ako ang calculator. So 1996 plus 1997 plus 1998 plus 9 plus 2,000. So mali na siya guys. So 9,900. Mali siya butang sa ubos ha. 9,990. I-divide na nimo siya guys og 5. Aniya, makakuha na ka sa iyahang kanisya dinhi. Kanisya. So makakuha na ka sa iyahang value. So divide na to niya siya 5. So muna na siya guys. 1998. So minus 1998 na siya. So unya na ta mag-solve na ha. Ato siyang i-continue og i-continue sa nato og himo atong table. So gamay nga x by imuha na siyang i-square. Sa next na sad, gamay nga x imo na siyang i-cube. Nya gamay nga x imo na siyang i to the power 4. Nya ang remaining ana guys nga kuan nga table is gamay nga x i-times nimo siya sa gamay nga y. Anya x square or gamay nga x imo na siyang i-square i-times nimo siya og y. So wala na siya guys nga mga equations nga dapat nimong i-kuan ibutang sa table or mo ni siya nga dapat nga mga ibutang sa table nimo guys kay para makasolve ka ani nga mga given equations. So, unsa na gani nakabutan ni. So, tolo ni siya ang itabunan ha. Siya gini. Okay. So, balik na ta. So, natin mong button guys is i-input mo ang mga values sa kada table. So, unsa may first nga kuan? So, kana siya. So, ang first nga x, so 1996 minus nimo 1998 equals to negative 2. So, negative 2. So, na guys, kani siya 1997 minus 1998 na negative 1. Yeah, kani siya guys. Kabato man tanan siya. So, kani niya 198 minus 198 equals to 0. Sunod ana kani siya 1. Yeah, kani siya 2000 minus 198 equals to 2. So na kay value ana guys. Sunod mag-value na sa sa iyahang x square. So kani siya. So ang imong kuan guys. So imong button guys, imo lang i-input ang kuan. Solve mo siya unsa may value sa x, negative 2. So 4. 4. Sunod ana negative 1. So 1. Niya kana siya guys. 0. 0. Niya sunod niya. Ana 1 niya 2. So kani siya 1 niya kani siya 4. So ano na siya guys. Sunod is mag-input ka sa value sa cube. So mag-input ka sa value sa kuan x cube. So unsa may value sa x cube? So ato na silang i-change guys. Value sa x cube. Yeah, solve na to. So may value sa x cube. So negative 2. So negative 8. Negative 8. Sunod value sa kuan. Iyahang next nga kuan. So negative 1. So 1. Negative 1. Negative 1. Yeah, kani siya guys. Kay basta 0 gani imuha yung cube gani. 0 na siya. So sunod kay 1. So 1. Ini ang last guys. Last yung may solve is 2. So 8 na 8. So na mag-ano sa ka, mag-input na sa ka sa value sa iyang x to the power 4. So na x na pila may value niya? Negative 2. So 16. 16. Sunod ana, ato na lang ni ana guys ha kay para kuan na lang Ito na may ko na. So, kana siya. So, sunod na guys, iyahang value niya. So, negative 1. So, 1. Ano sunod niya yung value. 0. 0. Sunod niya yung value is 1. 1 yapon. Ano next niya yung value, 2 is 16. So, muna na siya guys. Sunod is, mag-input ka sa second to the last value. Kana siya, second to the last value. So, tanan ko na, kay para dili matabunan ang y. So, ang next mong button na guys, i-times nimo ang x na gamay, kaning negative 2 sa kuan, sa iyahang y. So, negative 2 times 30 is negative 16. Ito na siya na, negative 60. Negative 60. So, negative 1 times 40. Negative 40. So, negative 0 times 62, 0. So, 1 times 55. So, 55. Kana siya. 60 times 2. So, 120. 120. So, I hope guys na nag-calculate na mo din na kay para makabaw mo sa konsisayop. Kay di mo ko perfect. So, na siya. So, sa next guys, kay mag-input na lang ka sa final na input guys, kay mas malibog. So, ito na siya i-calculate. So, negative 2 square times nimo siya og 30. So, pila man siya guys. So, 120. 120. Sunod nimong button guys, negative 1 square 40 is 40. Sakto ba? Sunod nimong kuan guys. So, 0 square nimo. So, 0. I-times nimong 62. So, 0 gihapon. Next mong button guys, kay kani siya. 1 square nimo 1. Times sunod nimong 55. So, 55. Ang last nimong column guys, kay kani. So, 2 square of 60. So, 240. So, nakakalculate na katanan guys. So, muna ni siya. Dali ra, di ba? So, ito ni siya yung console sa. So, muna ni guys, ang second mong button guys, kay i-add ang x, ipagitaan niyo siya iyahang mga values sa ubos. So, muna ni siya guys. So, 4 plus 1 plus 0 plus 1 plus 4. 10. So, 10. So, guys, kaya ni negative 8, negative 1 plus 0 plus 1 plus 8. So, 0. So, ito yung kitaan guys, kana 16 plus 1 plus 0 plus 1 plus 16. 34. So, ito yung kitaan guys, negative 60, negative 40, negative 60, negative 40, plus 55, plus 120. 75. Ano ang pinakalas guys, kana siya. Ito yung gamay na. Ang pinakalas guys, kana. So, 120 plus 40 plus 0 plus 55 plus 240. So, 455. Sakto ba ang pagkakalkyo? Sakto di ay. So, muna na guys, ang imuhang mga inputted values. Kani siya. Muna na siya mga inputted values. Kani siya guys, ato ni siya copy sa ubos. Kani siya. Kanilang silang tulo. Ato na siya ibutang sa ubos guys. Kani. Ato na siyang i-insert ang mga values niya para makabata. Edi kalimot guys sa n plus 1. So, n equals to 5. So, muna na siya guys. Next atong button guys. Sorry din, ako'y nakalimot nga value. So, ato din siya i-input guys, kaning y guys. So, pila man na guys. So, 30 plus 40 plus 62 plus 55 plus 60. Ano siya? 247. Kani siya guys, kay 0 ni siya guys. Kung ano ni siya calculate guys, negative 1, negative 2, negative 1, plus 0, plus 1, plus 2, na 0. So, kompleto na ka guys. Ang imuhang sunod button guys, kay imo ni siya i-indicate. So, kani siya guys, man yung summation of y. Kani siya, kaning na 0, man siya summation of x. Yeah, kani siya, summation of x squared. Kani siya, summation of x cubed. And yeah, last one is summation of x to the power of 4. Yeah, kani siya guys, man yung summation of xy. And yeah, kani siya summation of x squared to the power x squared times y. So, ano na siya guys? Yeah, ano na siya guys? May plug in din. So, saan na to? So, 247 247 equals to a. Pila ito tong n? 5. 5 plus b. Pila ang summation sa x? 0. Plus c. Summation niya, summation of x squared is 10. Na. Yeah. Ang summation sa xy, ang summation sa xy, 75. Yeah. A, summation of x, 0. Summation of x squared. Na, ito na siya ang tangang b, 10. Yeah. Summation of x cubed. So, pila man naman x cubed. So, 0 sad. Na, yeah. Kani siya, summation of x squared y. So, 455. Ano yeah, a ni mo? Yeah, summation of x squared. 10. Plus b. Summation of x cubed. 0. Ano yeah, plus c. Summation of x to the power of 4 is 34. So, kata na siyang simplify. So, ato na lang na siya i-type. So, 247 equals to 5a plus 0b plus 10c. And yeah, 75 equals to a. 75 equals to a 0a plus 10b plus c 0c. And yeah, 455 equals to 10a plus 0b plus 34c. So, mana na siya guys, mga imong gamiton para makasolve ka sa mga missing. So, kasi may missing niya guys, yung missing guys kay A, B, and C. So, magamit ta ni og mode 5.1. So, mode 5, mode 5.2 na guys. So, mana na siya guys. So, input na to ng value. So, ito na ibutangan din ha. Kani. So, mode 5.2. Kani siya may equation 1, equation 2, yung equation 3. So, 1, 2, 3. So, A, B, C, yeah, D. So, ano na siya guys. So, pila tayo mga A ni mo 5, B ni mo 0, yeah, C ni mo 10. Yeah, 247. Sunod din mo button guys is, kana siya A, 0, 10, yeah, 0, yeah, 75. Yeah, sunod mo button guys, kana, next, pinaka-last equation, A equals 10, B 0, 34, yeah, 4, 5, 5. So, muna siya na, hindi mo i-calculate ni guys, kana siya. So, pila mo na, 5, 0, 10, 247, yeah, 0, 10, 0, 75, yeah, 10, 0, yeah, 34, yeah, pinaka-last one is 455. So, kung mo na siya i-calculate guys, mo na siya makuha ang value. Kana siya. So, x ni mo na siya mong a. X, yeah, ato na siya indicate as a. Muna siya ang missing. So, pila man na guys. So, 1924 over 35. 1924 over 35. Yung approximated value na 54.97. So, duha lang ta ka decimal guys. So, 54.97. Sunod, imong y. So, y equals 15 over 2. So, 7.5. So, y nimo, muna siya imong b. So, pila to? 15 over 2 or 7.5. Yung imuhang c, kana, negative. So, imuhang z is mo na imuhang c. So, negative 39 over 2. Ay, negative 39 over 14 day. Sorry guys. So, pila mo na siya? So, 2.79. So, negative 2.79. So, muna na siya guys ang kuan yung nakuha nga value niya. Muna na siya guys ang kuan ang topic about least square using parabola. So, I hope you understand and thank you. Oh yeah guys, kalimutan ko og kuan circle. Sorry guys. So, muna na siya guys. So, I hope you understand the topic. And I hope na may search mo about sa least square fit because it's good. It's good at practicing niya. Sa ato asang sa ato asang subject karon sa structural, so magpangita ta sa mga unknowns especially sa indeterminate beams. So probably makabawasan mo sa paggamit sa iyong calculus, especially mode 5.2. Kabawasan mo interpolate sa mga problems. So thank you kay guys for listening and that is my topic. So hello guys, I'm back again. So today we'll be discussing about the square feet using cubic equation. So last time nagamit ta og quadratic parabola and the last one will be cubic equation. So mali siya ang cubic equation kani siya, naka na i-copy ha. Okay. Copy ta na. So, sa cubic equation guys, same ra gyapon imong buhaton para sa quadratic parabola or second degree curve. Yang imo ra gyapon ni siya i-extend nga nga equation, for example, kani siya y equals to a plus bx plus cx squared plus dx cubed. So, imo na siya extend. So, so summation of y equals to an plus b summation of x plus c summation of x squared plus d summation of x cubed. Sunod na guys, summation of xy, summation of xy, an, a summation of x plus b summation of x squared plus c summation of x to the cube, d summation of x to the fourth. Sunod, summation of x squared y. So a summation of x squared plus b. Nakasunod mo guys. So, kung continue ha. Summation of x cubed plus c summation of x4 plus d summation of x5 x to the power 5. So, ano na siya guys? Ang pinaka-last nimo guys. x cubed y equals to a summation of x cubed plus b summation of x to the fourth plus c summation of x to the fifth power, kanya summation plus d summation of x to the sixth. So kani siya guys nga mga equation, wala ni siya mong gamiton. Okay. So kani siya guys nga mga equation, wala ni siya mong gamiton para makasolve ka sa sa problem using cubic equation. So ato sa ni siya i-apply guys sa katong problem na to sa number 1. So kabaw naman to sa problem number 1. So kani. So ato ni siya i-copy guys. Ato ni siyang i-kuan. Na. So ato ni siya i-copy. Tang na to sa ubos. So kani siya ato ni siyang i-kuan. So ato ni siyang i-list doon. So pangalan to siya og calculate fitting a cubic equation. So y equals to a plus bx plus cx square plus dx cube. So muna siya ato equation guys. So sa kanan siya guys, kung ato ni siyang tan-awon sa ato ang sa taas na to kani siya, ato na lang ni siya i-copy. I-copy lang nato para dili ta magkalisod. Ato na siya i-copy. Anya, ang kani siya guys, ato ni siyang i-move gamay. Ini, i-move na to gamay. Anya, mag-add na sad ta guys og another na sad nga table. Tulo na sad ka table ato i-add. So mo na ato ang kuan atong gi-add nga table. So unsay bata nato? So ato na sa ni siyang i-input nga value sa atong calculator. So kung mo ni siya guys sa ato sa tabunan. So pila man na? So gamiton na to ang small x. So x 5 solve na to -2. So negative 32. Ito siya ni ko na. So negative 32. Sunod. Unsa may sunod niya? X negative 1. So negative 1. Kani siya 0 na ni siya guys. Kani siya 1. Kani siya 32. So palihog lang ko ha. So kani siya 1. Kati siyang isa, kaning 2. So, negative 32. So, nakasolve na ta sa kuan, x to the power of 5. Sunod, solve na ta sa x to the power of 6. Na siya, x to the power of 6. So, pila man na. So, solve sa tabalik. Solve na to na. So, pila man ang x to the power of 6. So, negative 2. So, 64. So, 64. Sunod ana, 1. Sakto ba? Sunod ana, negative 1. So, 1. Unya 0, unya 2 ay 1, unya 64. So na guys, ako na lang siyang gi-automatic lang nako. So that ang kanina dayong kuan small x gi cube na to siya, ning times na to siya y. So unsa may button na to? So ato ni siyang tabunan dinhi para makita na to ni ang y dinhi. Kani siya ang y. Kani siya. Kani. Nakita na to ni siya. Ato na siya ang a times ani. So saan na to? So negative 2 3 times na to siya og 30. So negative 240. Negative 240. Ito na siya kuan kay magbati man. Negative 240. Sunod kana siya negative 1 negative 1 cube negative 1 cube times 40 siya negative 40. Negative 40 kani siya 0 na ni siya guys, kabaw na taan na. So ni siya 55 niya kani siya ato i-calculate. So pila man na siya. So kana siya 2 cube 60. 2 cube times 60. So 480. Ni after na guys, nakasolve naman ta niya. Niya ato ni siya indicate. So mo ni siya ang imuhang summation of x of 5, niya kani siya summation of x of 6. Niya summation of x cubed times y. So mo na siya. Dali na kay, di ba? So ato na siya i-add guys. So pila na siya? Negative 32 plus negative 32, negative 1 plus 0 plus 1 plus 32 equals to 0. So 0. Sunod guys, kaya ang 64. So 64 plus 1 plus 0 plus 1 plus 64. So 130. Ano siya? 130. Yan, ang pinaka-last guys, ang kaning summation of x cubed times y. So negative 40 plus negative 40 plus 0 plus 55 plus 480. So negative 255 na siya. So muna na siya guys atong i-plug in niya n equals to 5 digyapon guys ha. So muna na siya guys ato i-plug in sa kani siya nga equation. Kani siya. So ato ni siya i-copy nga equation guys. Kani lang. Kani. Kaya ato ni siyang butang din dapita. So kani siya. So mana na ta. So mag-plug in na ta. So pila ito ang summation of y? Kani siya. Summation of y nimo 247 niya a 5 niya plus imong b niya imong summation of x equals to 0 niya summation of x square c10 niya summation of x2 plus d 0. Yeah, after na, ang kuan, yung summation of xy, so 75. 75 equals to, pila man na, a, yeah, summation of x, 0, plus b, summation of x square, 10, yeah, plus c c summation of x cubed kani 0 yeah, plus summation of x4 x to the power 4. So d 34 yeah, kani second to the last summation of x squared y. So 455 aniya kuan siya sige na a summation of x squared. So 10 plus b summation of x cubed 0 plus c summation of x to the power 4 34 aniya summation of 5 summation of x to the power 5 is 0. Aniya pinaka last nimo summation of x cubed x cubed times y. So 255 minus a summation of x cubed 0 plus pila man na b summation of kana x to the power 4 34 niya plus c summation 0 niya plus kuan summation of xc summation of x times c times the power of summation of x to the power of 6. So d times nimo to the summation of x to the power of 6. So 130. So ano na siya guys? Nya ko ato na siyang i-simplify. Ito na i-type ni. So 247 equals to 5a plus 0b plus 10c plus 0d. Yeah, 75 equals to 0a plus 10b plus 0c plus d34 34d. Yeah, sunod ana class kay 455 equals to 10a plus 0b plus 34c plus 0d. Sunod ana 255 equals to 0a plus 34b plus 0c plus 130d. So mano na siya guys imong equation nga gamiton nimo. So mo ni siya guys ang ato ang nakuha nga mga values. So kamo na lay kuan guys ha kanang pangita og way kung saan pag-solve ang 4 equations for unknowns. Daghan ni sa YouTube guys ng mga example guys, especially when it comes to elimination. So mag-eliminate ka sa mga equations, image lang add up, naka-i-eliminate nga variable para makakuha ka sa mga unknowns uban. So kung tan-aw nimo guys, ang kani siya nga akuan nga values kay same siya sa values na gikuha nato using second degree curve. So same rin sila guys. So I hope guys nga nakasabot mo and thank you for listening.